All right, today we're going to do lesson 9.7 on graphing rational functions. And we want to kind of look at what a rational function is. And it's a function that is p of x over q of x, let's just say. And p of x and q of x are going to be polynomials. Okay, so they're each a polynomial. And q of x cannot be equal to 0, right? We know that if this denominator is 0, it'll be undefined. It will not work, okay? So that is what a rational function is for review. Now we're going to look at the next section where it says use the information from the rational function below to determine how to find the x-intercepts, vertical asymptote, holes, domain, and range. Okay, and then we're going to fill in the table with our conclusions. So let's just kind of look at this table for a minute. I can see here that it's been factored and then it can be simplified. I know that the x-intercept is -1. Okay, so I'm going to kind of look at this and think, where would, if I were to equal any of these to -1, it looks like it would be the numerator right here after being simplified. Vertical asymptote is 3. Okay, so maybe if I highlight this a little bit, okay, I know that this could go with this. And if I have x equals 3, that's possibly can go with that part of the function. My 0.45, let me highlight this. Let's pick a different color. Okay, if I see 4, that could be something right here. Okay, and then my domain and range most likely are going to have to do with my asymptotes, right? So vertical asymptote obviously can't be 3 for x, and it looks like if there's a hole right here, I don't have that included in domain. Same thing for range. I'm going to look at my horizontal asymptote. Oh, we're not going to do that yet. That'll be in the next section. But I can see that it doesn't look like it's going to touch 1 here. It looks like this is going to kind of be a horizontal asymptote yet. Right there, we'll talk, like I said, we'll talk about that in the next part of these notes, but I can kind of see that there. And then I would say also the y value here for my range. Okay, so I'm kind of looking at this, just trying to figure out what could go with what. And then we're going to go down and answer this next section. I think I might try to make this smaller so we can see everything. Okay, so by looking at this, we determined that it's possible that my x-intercept has to do with the numerator, and it does. Okay, it's the simplified numerator equal to 0. Okay, the simplified. All right, so we actually are looking at this part only. And then my vertical asymptote, we said, is possibly with this denominator. So it is the simplified denominator equal to 0. Okay, so maybe if I put this like that might help you as well. Okay. All right, so we determined that the numerator simplified equal to 0 is my x-intercept, and my vertical asymptote is going to be the simplified denominator equal to 0. Now, if I'm looking at the whole, okay, it's a point xy where there's a break in the graph, and you can see it right there in the graph. And I can see that it's the common factor in the numerator and denominator equal to 0. Okay, so if there's a common factor in the numerator and denominator after you factor this before you simplify, that is going to be your whole. And it's going to be your x value of the whole. And what you can do is substitute it back in, okay, and into the simplified version, right? Because if you put it into the original, it would make this 0 and it would make the denominator 0. So we'll take it and plug it into the simplified version to get the point. Okay, so I plug it in here. You can see 4 plus 1 is 5. Divide by 4 minus 3, which is 1. So I would have 5 as my y value. Okay, it is a point. The whole is a point. All right, and then we talked about the domain a little bit. It's going to be all real numbers except for your vertical asymptote and the x value of the whole. If we look at the range, it's going to be all real numbers except for your horizontal asymptote and the y value of the whole. Okay, so like again I said, the horizontal asymptote is going to be this y equals 1 in this example, and then our y coordinate for our whole, okay, the y value. All right, so if you're looking looking at graphs and looking at the function, you can easily determine based on the function and factoring it how to graph the actual function. So we still need to learn about horizontal asymptotes. So let's go to the next page. Okay, and the horizontal asymptote, you're going to determine the horizontal asymptote by looking at the degree, okay, of p of x and q of x, right? Remember, p of x is your numerator and q of x is your denominator. Okay, so we're going to look at the degree, and the degree has to do with the exponent, the highest exponent in each. So we know in here, this is 1, and this is x squared, so this is 2. So the degree here is 1, and the degree here is 2. So I'm going to go and graph it. I want to graph this function to help me determine what is the horizontal asymptote. Okay, so here is the first one. F of letter A, x divided by x squared minus 2x minus 3. And I can see that my horizontal asymptote is going to be y equals 0. I know that it crosses right here. Horizontal asymptotes the graph can cross it, but vertical asymptotes do not. But you can see right here, we're still treating it like a horizontal asymptote because this part of the graph is getting close to that line but will not touch. So if I go back, I can say that my horizontal asymptote is y equals 0. All right, so we have that information. We're gonna look at all these graphs first to find the horizontal asymptote before we can determine what it means down here. So I'm gonna go back to my graphing calculator. I'm gonna go to y equals. I have all of these graphed already, so we can quickly look at them. Just need to highlight. Okay, let's look at the next one. This is letter B. All right, and if I look here, I can see that it looks like it's getting close to y equals 2. Okay, y equals 2, and it is not going to cross it or touch. So I'm going to say y equals 2 for this one. And let's look at the last graph. Okay, letter C. This is h of x equals x cubed divided by x squared plus 3x minus 10. Okay, and I'm looking at this and I don't really see a horizontal asymptote. Okay, I see oblique asymptote, which we'll talk about in pre-calculus, but I don't see anything where this line is getting close to some kind of y equals a number, like y equals a. I don't see anything. So I'm going to say in this case there is no horizontal asymptote. Okay? All right. So if I look back at this, if the degree of p of x is less than q of x, and in this case, the degree here is 1 and this is 2. So p of x, so this goes here, this one matches this one, we can say the horizontal asymptote, okay, oops. All right, the horizontal asymptote is going to be y equals 0, okay? And if I look at this one, the degrees are the same. So I'm saying the degree of p of x equals q of x. I notice that it's 2. And where did I get that number 2 from? Well, we're actually going to get it from the leading coefficients. Okay, and it's 2 over 1. So the horizontal asymptote is the leading coefficients of p of x divided by q of x. Okay, so in a way you could say it's y equals a over b. Okay, and whatever these leading coefficients are. So a would be 2, b is 1. So that is going to be our horizontal asymptote. Okay. And then if the degree, this degree is 3 up here, and this one down here is 2. So if the degree of p of x is greater than q of x, there is no horizontal asymptote. All right, so these are kind of the rule of thumb for finding horizontal asymptotes based on the graph. Okay, you just have to look at the degree of each. Remember, if the degree up here is less than the degree down here, you have a y equals 0 horizontal asymptote. If they're equal, it's going to be the leading coefficients. And if the numerator is greater than the denominator for the degree, then there isn't one. Okay? And you can look down here where we can see that it's just some things to remember: how to find the vertical asymptote, horizontal asymptote, and finding the whole. Okay, let's just do a couple examples. Let's do letter A. Okay, factor the rational function if possible, identify the characteristics, and sketch a graph. All right, so first thing I need to know is what does it look like in factored form, so I can identify the intercepts, asymptotes, and whatnot. Okay, so I'm going to factor it, and in factored form it's f of x equals, factor out a -3 x minus 1 divided by, and this is going to factor to x times x plus 3 times x minus 1. All right, it's not simplified yet. I know I can simplify it a little further. All right, so I know the x minus 1s will cancel. I'll end up with -3 over x times x plus 3. All right, so to find the x-intercept, I'm going to look at the factored portion in the simplified version of the function. Well, there is no x in the numerator, so there isn't going to be an x-intercept, right? We're looking at the numerator, and I don't have an x plus 1 or x plus 5 or anything like that, so there is no x-intercept. For the vertical asymptote, I look at the simplified version, and I take each x value, or portion of that, equal it to 0, right? So I know for the vertical asymptote, I'm going to have an x equals 0 for this part, for this guy right here. And then we'll also have x equals -3 for this part right here. Okay? I know there's a whole if I have common factors in the numerator and the denominator. And so I know that my whole is going to be x equals 1, and I'll substitute it back into the simplified version, and I will get -3/4 as my y value. My horizontal asymptote, I'm looking at the degree. I have degree of 1 here and 3 here, so I know the numerator is less than denominator, so I'm going to say my whole is my horizontal asymptote is y equals 0. Okay, and my domain, x equals, x is all real numbers, except for x cannot be 0, and it cannot be -3, looking at our vertical asymptotes, and it cannot be 1 for my whole. And the range, y is all real numbers, except for it cannot be 0 for the horizontal asymptote, and it can't be that y value of the whole. Okay, and then you can sketch the graph from this information. You can also double check using your graphing calculator and make sure you graph it right. The graphing calculator will not show you the whole visually, so you need to really do this analyzing by factoring and simplifying to find all this information. And then you can sketch your graph with your asymptotes. Okay, let's move down to this part. Write a possible rational function given the information. Letter D. All right, so I'm going to write a function based on my information. All right, so if I'm looking at x-intercepts, I know that has to do with the numerator. So I know my numerator is going to be x plus 1 times x minus 3. I know I have vertical asymptotes of 1 and 5, so that would be my denominator. There is no whole, which means I don't have any common factors. And my horizontal asymptote is 1, which means that my p of x equals my q of x because I have leading coefficients of 1 here. Okay, so I have the same degree, which is true, and so that is my function. I don't need to put the 1s there. Okay, so do the practice on your own, and then check it before you start the homework. All right.